students, this is Dr. John, your physics and math professor. We have another parabolic quiz or exam type of question. This is another word problem. I've written out the whole problem there underneath, but I've just put a couple of details up here. So there's a fountain that is spraying, water spraying from the center of a large fountain, and they've modeled the spray of the water to follow this path. The height, h, where h is the height of the water above the fountain, is equal to minus 2/3 d squared plus 4d. H is the height above the fountain, and d is the horizontal distance from the base. They want to know how far does the water travel in the fountain. One of the big challenges to these kinds of problems is to understand what they're saying and to find a way to sketch some sort of picture. So I've done that here for you ahead of time. I've taken this, here's this water fountain, here's the origin of the fountain right there, and water spraying out in all different directions. Put a few things in there, so water's coming out like this, and like this, spraying out in all directions. And they've modeled this water to say, starting from here, from the center of the fountain, it goes a certain distance and it has a certain height. That you can model this way. The height with respect to the distance, so it's a function of the distance. This is like y being a function of x. This is the y, which is the height, which is normally the way we would have it in a y coordinate. I'm going to draw the y coordinate in here. This is the y coordinate, and this is the x coordinate. Just like we normally do, only we've called them h and d here. So what we want to do is find out how far they go, how far the water goes here. In other words, what we want to know is this equation here, when will h equal 0? Obviously, h is going to be equal to 0 there, but at what distance d will h equal to 0? So I'm going to try to solve. I'm going to erase some of this stuff here. We don't need this right now. I am going to try to solve this. Give me a second. So here I've rewritten this same equation here, just copied it down here so we can work with this one. And what we want to know, remember, is we want to know what the distance d is. In other words, what d will be when h equals 0. So let's just plug in h equals 0 right here and see if we can solve this. Now we could use the quadratic formula, we could factor, we could do find this a number of ways, but let's just see if we can really do this in a much simpler way. Notice there's a 2 in this and there's a 2 in this. Let's try to take that out. Minus 2. And there's a d in each of them. Minus 2d. I'll take that out of there, and I'm going to be left with 1/3 here times d plus 2. I already took a d out of here and a 2 out of there. Actually, I'm going to have to make this a minus 2. Because I took a minus 2 out of that. So this takes care of the minus here. Double minus makes this a positive. Okay, so I factored this here together, and we wanted this to be equal to 0. And remember what we've had before, if we have two things that are both multiplied together to equal to 0, one of them has to equal 0 or the other one has to equal 0. So in this case, we have this, so minus 2d has to equal 0. We can divide both sides by minus 2 and just realize that d has to equal 0. So I'm going to write that over here. So d equals 0. We don't need this term anymore. So now we just want to look at this term. What if this term here equals 0? I don't need that. I don't need that. I just want to make this all equal to 0 now. Well, I can take this 2 to this side, and I'm going to have 1/3 d is equal to 2. Now I can multiply both sides by 3, and I get d equals 6. So there's my second answer. Normally, often you're going to have two answers on these quadratics. You can have 0, you can have 1, or you can have up to 2. So just take a look at this picture here. Obviously, one of the solutions for when the water is at 0 is where it starts. That's when d is equal to 0 distance. The other one is where d is equal to 6. This distance here is 6 meters. We didn't mention the units here, but let's say it's meters, so this would be 6 meters. That's what they wanted for the answer, and I hope that helps. If it did, we will see you in the next video. Bye-bye.